Hi everyone, my name's Steven. I'm a fourth year at Case, and today I'm going to go over a sample step one question about the physiology of pregnancy. So first, we always want to start off by reading the question stem and the answers. Which of the following mechanisms best explains these findings? A. Decreased sensitivity of maternal tissues to insulin due to placental hormones. B. Autoimmune destruction of pancreatic beta cells. C. Increased maternal glucose utilization for fetal energy needs. D. Suppression of maternal glucagon secretion by placental hormones. Or E. Reduced hepatic gluconeogenesis secondary to fetal glucose uptake. Unfortunately, this didn't give us a lot of information, but just from the mentions of sort of insulin, beta cells, glucose, and glucagon, that should sort of prime you to think about blood sugar and blood sugar regulation. So we know that's what this question is going to be about. And based on some of the answer choices, for example, B, autoimmune destruction of pancreatic beta cells. What does that remind you of? That should remind you of type 1 diabetes. So, just a couple of things to keep in mind as we go through this question. A 32-year-old woman in her third trimester presents for a routine prenatal visit. She reports increased thirst and frequent urination, but no other symptoms. Vital signs are normal. Fetal growth is appropriate for gestational age. Lab results show fasting plasma glucose of 180 and a fasting serum insulin of 25. So now let's think about these labs for a little bit. So we have a fasting plasma glucose of 180. We know that's elevated, and fasting serum insulin that's also elevated. And even if you don't know the mechanism of why this might happen in pregnancy, it should still be pretty recognizable to you that this is likely some sort of insulin resistance, because even though we've increased our insulin, our blood sugar is still too high. So now let's sort of review these answer choices and see which one fits best with insulin resistance. So A, decreased sensitivity of maternal tissues to insulin due to placental hormones. Now, this sounds right. This fits in with what we just said about insulin resistance, but let's move on to the others just to make sure. B, autoimmune destruction of pancreatic beta cells. So, as I was saying before, this best describes type 1 diabetes. Now, can you have type 1 diabetes in pregnancy? Yes. But is there any sort of association with pregnancy and new onset type 1 diabetes? Not really. So, I'm going to mark this off. C. Increased maternal glucose utilization for fetal energy needs. While this is true that the mother needs more glucose to account for fetal energy needs, what would we expect from our blood sugar? We would expect it to drop, so we can pretty confidently mark this as wrong. D. Suppression of maternal glucagon secretion by placental hormones. Now, if you knew about the physiology of pregnancy, you'd know that this really isn't true. But even if you didn't, just think about what suppressed glucagon would actually mean. So low glucagon would suggest that the blood sugar should also be low, but in this case, the blood sugar is too high. So we can roll this out. E. Reduce hepatic gluconeogenesis secondary to fetal glucose uptake. Again, if you knew about the physiology of pregnancy, you would know this is false, but let's think about this. If we have less hepatic gluconeogenesis, how would that reflect in our blood sugar? It would be low. So that means we can also rule this out. Now, looking through it, our best answer choice is A, which is the correct answer. In pregnancy, uh, the syncytial trophoblast produces human placental lactogen, or HPL, and that increases maternal insulin resistance. Why does that happen? One of the easiest ways to remember this is to think about the glucose needs of the fetus. The growing fetus needs lots of energy and therefore needs lots of glucose. By increasing maternal insulin resistance, the blood glucose levels also increase, and this ensures a constant source of glucose for the fetus. And this is also one of the primary mechanisms driving gestational diabetes, so it's very important to recognize and understand.